Here's my solution to the dailyintegral.com easy integral for December 15th, 2025. The question was the integral from 0 to the natural log of 2, the square root of e to the x minus 1 dx. So my first instinct here was to do a u substitution. I'm going to let u equal the entire inside, so u is e to the x minus 1, and then dx is just e to the x dx. If you change your bounds, u is going to start at e to the 0 minus 1, or 0, and u ends at e to the log 2 minus 1, which is just 1. Performing the substitution, we get the integral from u equals 0 to u equals 1, the square root of u, and then when you solve for that dx, you're going to be left with u plus 1 in the denominator, so you get root u over u plus 1 du. But it turns out this function isn't that easy to anti-differentiate, but if you recognize that u is actually the square root of u squared, we can do another substitution that'll help us a lot. We're going to let w equal root u, so dw is 1 over 2 root u du. W is going to still start at 0, and W is still going to end at 1. And then one more thing, we're going to recognize that du is actually 2w dw when you cross multiply by that denominator. So we're left with the integral from 0 to 1, 2w squared over w squared plus 1 dw. So we've reduced this integral to the integral from 0 to 1 of 2w squared over w squared plus 1 dw. Now here I'm going to add 0 in a clever way. I'm going to add 2 and subtract 2 from the numerator, and then we can split up that fraction into two parts. We get the integral from 0 to 1 of 2 times w squared plus 1 over w squared plus 1, and then minus 2 times 1 over w squared plus 1 dw. And now both of these integrals are pretty straightforward to integrate. The first one is just 2 evaluated from 0 to 1. And then you're going to say minus 2 times arctangent of w from 0 to 1. Well, since arctangent of 1 is pi over 4 and arctangent of 0 is 0, you get 2 minus 2 times pi over 4, or 2 minus pi over 2. And that's our answer. Pretty nice.